Alright, hello everyone, welcome to your first video on derivatives. So the first thing they usually teach you on derivatives is the definition of a derivative. And it tends to be very confusing at first because it uses limits and it's not exactly something you'd expect. But the easiest way to understand it is just try your best to grasp the theory of it and use the actual formula when they tell you to. So the actual theory goes like this: we suppose that there's some value x and there's some other value x plus h, let's just say, and there's a y value of x, obviously called f of x, so just like before, and there's a y value of x plus h called f of x plus h. And what's going to happen is they're going to give you some sort of line here, and between this point and obviously the f of x plus h, there's also this we're going to talk a little bit basically about convergence. So the idea is that we're going to find a limit when these 2 points will get eventually closer and closer. So we'll have this line that represents it converging. So these points will converge closer and closer and closer and closer and closer until they are just one value. And that one value will represent this kind of curved line, which is going to be the slope of a tangent line. And the slope of a tangent line is the derivative, and we'll come back to that at another point. But just know that from this theory here, to get any derivative, we take the limit of h, which remember h was this one, so h approaching 0, and it's going to be equal to f of x plus h minus f of x, so just minusing these two from one another, remember, because the point's going to converge on the limit, over just the value h. Okay, and that's the expression we're going to deal with. So even if you find the expression kind of difficult to understand where it's coming from, just know all you're expected to do usually in a class is just apply this formula to some sort of function to prove that the derivative works using limits, which is why you learned all about limits partly in the first place. Okay, so now that you understand the basic idea of what a derivative is, which remember it is just the slope of a tangent line, we're going to try out a few problems that they'll give you the definition of the derivative for. So let's say we had this function. Let's say it was f of x is equal to 2x minus 1. And let's just say we had the point 1, 1. Because we're going to use this point later, because once we find the derivative, we can very easily use that to find the slope of a tangent line. And you'll see what I mean. So let's just practice using the formula, though. So we know that it's going to be the limit as h approaches 0 of the f of x plus h minus the f of x over the h. So you might be asking, though, how do I do this? How do I plug this function in to this limit? So what we would do is you would basically, everywhere you see an x plus h, an x, you put an x plus h there instead. So you would, of course, rewrite the limit like you would normally, and then you're going to put 2 multiplied by, so there's an x, so x plus h, you're putting it in instead. You carry over the minus 1, so minus 1, and then you're going to subtract, so you're just carrying over the minus, and you're just going to put f of x, you're going to repeat it for f of x. And remember to put parentheses, because if you don't distribute this minus sign, you're not going to get the right answer. So the f of x is 2x minus 1. And of course, it's going to be all over h. Okay, what do we do now? Well, let's rewrite the limit. And let's see if we can't simplify this a bit. So your goal is always going to be simplifying the um, the actual limit until you can get rid of the h and on the bottom and plug in 0 to get whatever the derivative it is. So if we distribute this 2, we'll get 2x plus 2h minus 1. Remember, we're going to distribute the minus sign, so minus 2x plus 1 over h. And you're going to find that a lot of stuff starts canceling. So let's rewrite the limit first, though. So what can we do? Well, as you can see, the two x's cancel, so we can cross out these two x's. We can cross out the minus and plus 1 because they're opposites of each other. So we'll be left with 2h over h. Okay, what do you think we can do now? Well, we could cross out an h because now we can cancel out those h's since they're alone. So the limit as h approaches 0 just ends up being 2. So it's just a single constant. So the slope ends up being 2. So we can't actually use this slope, this point, to find a slope because it's already a slope. Why do you think that is? Why is this linear function already, why does it give you just a slope inherently? Well, the answer is because the linear function, if you recall, looks like this. It's already a slope line. It's already linear. So when you solve for it, the derivative's slope of the tangent line is just going to match up to the already existing slope. So that's why your derivative, which remember is just the slope, so the m of the tangent line, is going to match. But let's practice with one that doesn't give you something that's already the slope. Let's practice with something that's not a linear function to understand how it might work. Okay, so let's try something like maybe f of x is equal to x squared minus 7. Let's try something like that. So how would we do x squared minus 7? And then I'll give you a point that we'll use later, which will be 2 comma negative 3. So how would we do this? Well, again, let's use that formula. So we're going to plug in x plus h wherever we see an x. So we see an x right here. So x plus h, we'll square that whole thing, minus 7 minus the f of x, which was x squared, minus 7. And it's all going to be over h. And remember, this is the limit as h approaches 0. Okay, so what do we do now? Well, let's try to simplify some things and see if we can't see if it can work its way out. Okay, because usually they'll work themselves out. So if we FOILed x plus h multiplied by x plus h, we always get the same thing. So we'll get x squared plus 2xh plus h squared, and it's going to be minus 7, and then it's going to be minus x squared. We're just, remember, distributing this across, minus x squared plus 7. And then we'll have this h here as well. So what can we do? Well, things look like they're going to simplify already. So the x squareds cancel, the 7s cancel. So what we're left with is the limit as h approaches 0 of 2xh plus h squared over h. Now what should we do here? Because we can't just get rid of this h on the bottom like before, because we have two terms here. Well, what you want to do is you want to take out an h. So let's take out an h and see what we'll have left over. So if we take out an h, we'll have an h, and it will be a 2x plus just an h, because this is an h squared, over an h. And now what can we get rid of this h? We can, because the h is by itself. So let's get rid of the h, and then we'll have the limit as h approaches 0 of 2x plus h. So can we plug in the 0 now for the limit? We can, because the h is gone on the bottom. So let's do that. We'll have 2x plus 0, and of course that's just 2x. So the derivative, or remember the slope of the tangent line, ends up being 2x. That is the answer. Now how do we use this point 2, -3 to find the point, the slope at that point? Well, what you do is, for now we're just going to find the slope. Eventually we might want to find the entire equation of the tangent line, which might be useful later, but for right now let's just worry about finding the slope with this point. So because we want to find just the slope, all we do is we plug in the x value from the point, so 2, we multiply it by whatever the original derivative was, and we'll get that the slope of the tangent line for this point, remember, is going to be 4, but the actual derivative, remember, is 2x. Okay, so now that you have a better idea of it, let's try one more, and let's see if you can't figure this one out too. And this one will be a little bit more challenging than the previous one, but it'll work out just the same. So let's say that we had the function f of x equals to 1 over x. So just 1 over x, that's it. And let's say it was for the point 2, comma 1/2. Okay, how would we do this? Well, let's start off the same way and see if it can't work its way out like it's been doing. So, limit as h approaches 0 of just 1 over, and let's remember it's x plus h. We replace x of x plus h, minus, and then it's just going to be 1 over x, so just this, and we're going to be over an h. So what should we do here? Because it's not clear there's no factoring, there's nothing we really can do to simplify it like before. Well, it turns out there is. We just have to take common denominators to get rid of this fraction here. So the common denominator between x and x plus h is just going to be x multiplied by x plus h, and we're going to do that for both the bottom and the top. So this is just kind of simplifying it. We're not changing the equation at all. So if we were to do this out, we'll get that this one will turn into x, because the x plus h's cancel here. So we'll get x minus the x's cancel, so x plus h. And then we'll get that it's going to be h multiplied by x, and then by that x plus h. So again, we're just kind of putting this next to the h. Okay? So is there anything we can do here? Remember to put this thing right here to make sure that we're distributing it. So just to make sure you're following, what we would want to do is we have x minus the x, okay, and then minus the h. Okay, so we'll rewrite that so that it's clear where that's coming from. So if we were to rewrite this, we'd have the x, because we're distributing the negative, so x minus the x minus the h over the hx multiplied by x plus h. So obviously these x's will cancel, so we're left with just a negative h on the top, and that's good for us because we want the h's to go away, and also lucky for us, everything's being multiplied on the bottom, so we can get rid of the h here. And what will be left over? Will be left over with just that x and that x plus h on the bottom. So we'll have a negative 1 because the h is now gone, and it will be the x from before multiplied by the x plus h. Okay? And now, if you notice, there is no problem with there being a number there, because if we were to plug in 0, we wouldn't get it in indeterminate form. So let's go plug it in then. So we'll get -1, and the x stays the same, so it's going to be x multiplied by x, remember plus the 0, so plus 0, that gives you -1, x multiplied by x, which remember, x by x is just x squared, so we can simplify that a little bit further. So that's going to be x squared. So the answer to this, I apologize, that's a terrible x squared, is going to be -1 over x squared, and that ends up being the slope of our tangent line. So this is our derivative answer. The only difference is we're going to basically find the slope of this line. Okay, so to find a slope, just like before, you'll want to plug in, so the slope's going to be just taking that derivative we just found, take the x from here, so 2, we're going to square it, right? We'll get -1 because we're just putting in 2, and we'll get -1 over 4, or a -4th, and that's going to be our slope. So if you're wondering why are we finding this slope, I'll show you really quick in this example. So I'm going to erase the whole limit process, and let's remember that our slope was -1/4 for this point. So for the point, remember, we were dealing with this point 2, comma, 1/2. And remember, we already found that the slope of the tangent line here is going to be -1 over 4. And usually what we'll want to find after that is a slope of the tangent line, which will help us understand certain things about a function. So if you recall, to find the slope in y-intercept form, we would need the equation y minus y1 equals to m times x minus x1. So the x1 is going to be what we put the values here in, and the y and the x are going to remain the same. So do we have the x? The x we do. We have the y. We have the m. Remember, this is the m of the tangent line. So we can now plug things in. So y minus our y point is 1/2 and equals to our slope, which is 1/4, and our x point was going to be the same as before, so minus 2. Okay, so now we just kind of have to simplify. So we'll get y minus 1/2 equals to -1/4 x. And if we multiply -1/4 by 2, we'll end up just getting, and that's going to be a positive 1/2. Remember, because that's positive 2 over 4, so that's just 1/2. Okay, and now we just can add a 1/2 to get the y by itself, so we're in true y-intercept form, which is usually what they'll ask for. And this will be -1/4 x, and then 1/2 plus a 1/2 is just 1. So the slope of the tangent line, so remember, this is the slope of the tangent line, which also, remember, is also just this is the derivative. So the derivative is also the slope of the tangent line, but this is what we solved for. So the slope, this is the line. So the slope, remember, was this part right here. So the slope was this. We found the equation, but the slope we used for it was this -1/4. Okay, so this is the introduction to the definition of derivative and how you can apply it to find the slope in the equation of a tangent line. Just remember that when we eventually look at other things, like all the rules, we'll find more complex derivatives. We won't have to use this definition all the time. We have rules to help you with that. All right, hope this helped.